Chapter 8 is on chemical reactions. We're going to focus in Chapter 1 on chemical properties and changes. And in order to discuss those things, we have to talk about the differences between physical properties and changes and chemical properties and changes. Remember that a physical property, and we covered this in the last chapter, is any characteristics of a substance that can be observed without changing the identity of the substance. Examples of that are taste and color. Both of these are physical properties, and there are no changes in terms of the substance and what it's made of. In order for us to determine those physical properties, we don't see any changes, and no changes occur. In order for us to see chemical properties, however, we have to see or experience, or there has to be some sort of change. So chemical property is the ability or inability of a substance to combine with or change into one or more new substances. And the picture that you see there is an example of potassium and water. And there's a semi-violent reaction between potassium and when you drop it in water. And so let's take a look at a YouTube video on that. Okay, so we saw with that video, one of the chemical properties of potassium is that when it is in water, it reacts and changes into a gas and a smoke. So that's a pretty good example of a chemical change. What chemical properties describe? First of all, they describe a change of substance. We just saw in the previous video how a substance was changed from one form to another, and from one thing to another. A couple of examples are a sliced apple. When it sits out, it eventually turns what? Brown, right? That's an example of a chemical property of the substance we call an apple. An old abandoned car slowly, if it's left out in the rain, begins to rust, right? So it's another example of a chemical property in terms of how metal changes to rust. Chemical properties also describe conditions under which a substance does not change. So an example of that is helium gas does not burn. So in order to see that, we would have to, of course, to light the gas to see if there is a combustion reaction. And with helium, there is not. So that is one of the chemical properties. It's actually describing something that is not the case with that substance. Another example is gold and platinum that do not corrode. A lot of other metals corrode, but gold and platinum do not. It's what gives gold and platinum their value. We all know that classically gold is very expensive and very valuable. Well, that's one of the properties, the chemical properties that makes it very valuable, is that it doesn't corrode, it doesn't break down over time. Here are some physical properties of things that we're real familiar with. The substance is on the left and the physical property is on the right. Take, for example, water. A physical property of it, it boils at 100 degrees Celsius. Silver is a good electrical conductor. So as you might imagine, silver, along with other metals, is used in electrical wiring. Table salt, or sodium chloride, melts at 801 degrees Celsius. It's a physical property. So, let's not forget, we're talking about physical properties here. So if table salt melts, it doesn't lose its structure, its chemical structure. It is still sodium chloride. It's just in a different form. Another substance is diamond. It's extremely hard, one of the hardest materials known to man. Baking soda is a white crystalline powder, so we're describing the physical property there as being a color and a texture. And then mercury, which is classically described as one of the only metals that is a liquid at room temperature. We use it, of course, in old temperature gauges, thermostats, etc. Let's take a look at chemical and physical changes and what is characteristic of both of those, or what is true about both of those. With chemical changes, hold on a second. Okay, I had the arrows pointing in the wrong direction there. So let's look at chemical first. So the arrow to the right shows the characteristics of chemical changes that are typical. Chemical changes are not easily reversible. In other words, if there is a change that takes place chemically, it's hard to make that material go back to what it was before you changed it chemically. Another thing is that the properties change when you've changed something chemically. The properties will often change from what you had to what you now have as a new material or new substance. An example of that is iron. If we leave it out in the rain, if we leave it out in any kind of wet conditions, it's going to become turned to iron oxide. Even though the name iron oxide is very similar to iron, iron oxide is nothing like iron. It's altogether different. And so when taking a look at the picture right there, the chain is turning different colors. Well, that reddish color is actually iron oxide, which is completely different than iron. Let's take a look at physical changes and what's characteristic of those every time. First of all, they're reversible. An example of that is ice melting to water. Of course, we can put it back into cold enough conditions and it will change back into ice. So it's reversible. And it doesn't form a new substance. If we look at the particles, the atomic or molecular particles in water, we'll see that it's a compound we call H2O. If we look at it in ice, it's a compound called H2O. So it's not a new substance, it just takes on a different form. There are basically two kinds of chemical change processes. Okay, so again, this is key. We're talking about chemical changes, and there are basically two types of processes that materials will go through in order to change chemically. The first one is called decomposition. When something decomposes, that means that it breaks down. It turns from one thing to more than one thing, or say two things into more than two things. So that's what decomposition is. The example that you see there is of actually just water. This is just water. And electricity is being applied to the water, and a technological machine is used to pull out the parts of water that make it what it is. And we all know that water is H2O, which is hydrogen, 2 parts hydrogen and 1 part oxygen. So what you end up with is on one side is oxygen and on the other is hydrogen gases. The second kind of chemical change is called compounding. It's the opposite of decomposition. Compounding is taking two things and turning it into one. And you should recognize with compounding that word compound. A compound, remember, is the result of two or more atoms or molecules combining to give you something altogether new with different properties, etc. So the second kind of chemical change is called compounding, and the classic example is of NaCl, which is sodium chloride. 1 part sodium ion to 1 part chloride ion gives us salt. Okay, that's called compounding. Let's take a look at a video sort of as an overview of this lesson. The video is called Physical and Chemical Changes, YouTube video. And after we watch that, that will end Lesson 1.